Hello, my name is Anish and today I'm going to explain how to prove root 2, root 5 or any number given in the question is either rational or irrational. In order to understand that, let's quickly understand what are rational and irrational numbers. A rational number is a number which can be represented in the form of P by Q, where P and Q are co-primes and Q not equal to 0. P comma Q belongs to integers. What are co-primes? Co-primes are the numbers which have their highest common factor, only common factor as 1. For example, 4 by 3, 5 by 7 and 3 by 2, whatever. These are co-primes. Now, an irrational number is anything which does not follow these rules. An irrational number cannot be expressed in the form of P by Q with the following criteria. Now, if you want to comment with the help of the decimal expansion of the number, whether the number is rational or irrational, you can use this. A number whose decimal expansion is non-terminating and non-repeating is called an irrational number. And try to tackle these conditions one by one. If a number is terminating, end of story, it's a rational number. If it is non-terminating, then go for the second statement. That is it non-repeating as well? If not, then it's a rational. If yes, then it's an irrational number. For example, you can take 12 divided by 5 is 2.4. It's terminating, end of story, rational number. Now say 4 by 3. 4 by 3, 1.33333 so on. It is non-terminating for sure. But you can see that this 3 is constantly repeating. So it is a rational number. Now let's take root 5. Yeah, let's take root 5. So decimal expansion is 2.2360679 so on. It is neither terminating, neither there is any repeating pattern, as you can observe. So it definitely is an irrational number. But how to prove mathematically is a different story. In order to prove, we need to understand this particular theorem, fundamental theorem of arithmetic. What it says is that any composite number can be expressed as a product of prime numbers and it is unique apart from the order in which the prime factors occur. So what it means is that, as you can see, you have learned how to factorize before, and you can see that 54 can be written as 2 into 3 power 3. And no other number can be represented in this particular format. No other number, when you factorize it, will give you the same answer. And what does this statement mean apart from the order in which whatever? What this statement means is that I am not counting 3 power 3 into 2 as a different entity from 2 into 3 power 3. I am not counting 3 into 3 into 2 into 3 or 3 into 2 into 3 into 3 as a different entity. For me, everything is equivalent. As long as I am not double counting it, then as long as order does not matter to me, then the statement holds true. Okay? Now, let us go to irrational number and let us try to understand this theorem. This theorem comes from the fundamental theorem of arithmetic that we just discussed, and this is an application of it, and we are going to use this for our proof. Now, what this theorem says is that let P be a prime number. If P divides A square, then P also divides A. where a belongs to integers. Now, what does this statement? Let's prove this statement. What it says is that p is a prime number, which is the most important criteria for this theorem. If p is a prime number and it divides a number a square, that also divides a. You can intuitively understand, but let's try to prove it mathematically. Say a square can be written as p1 square into p2 square into p3 square, so on so till pn square. A can be written as p1 into p2 into p3, so on till pn, like I've written here. And this can be further factorized like this. Fine. Now, once we've written a square like this, let's assume p is any one of the pi, I belongs to 1 to n. P is either p1, p2, p3, any one of the pi. Why it has to be any one of the pi? Why not the multiplication of the two prime factors? Because our initial condition is that p is a prime number. For this statement to hold true, for this theorem to hold true, p must be a prime number. For example, 36. 36 can be written as 2 square into 3 square. Now, what I'm saying is that p can either be 2 or p can either be 3. Why not 6? Because 6 is not a prime number. Why not 9? Because not a prime number. Why not 4? Because it's not a prime number. So p can either be p1, I'm calling this as p1, I'm calling this as p2, right? So p can either be p1 or p can either be p2. And the same in this statement, that p can be any either p1, p2, p3, so on till pn. P can be any one of them. So I can write a square as the product of the respective pi and p. Assume p3 is p3 equal to p. The third prime factor is our p. So a square can be written as p1 square into p2 square into p square into p4 square, so on till pn square. Now let's rearrange the terms. I can write this as, I'll take one p common, p into p1 square into p2 square into p into p4 square, so on till pn square. You can see that if I call this entire product as a number c, then a square can be written as p into c. Which means what? In the multiplication table of p, definitely a square will come somewhere. Right? P into c is equal to a square. Now, let's think about a now. Let's try to think about a. A can be also represented as p1 into p2 into p into so on till pn. Now again take p common, p1 into p2 so on till pn. Now a can be represented as p into some n, some number n, or say m, or say k, anything. So you can see from this is that if p divides a square and it's a prime number, then p also divides a. That's the mathematical proof. Now in order to get some feel, you can see that here 64 can be represented as 2 power 6, and you write this like this, and the only choice for p in this particular case is 2. You cannot take p as 4, you cannot take p as 8, because it won't be a prime number anymore. Take the square root of this 64, you get 8, and you can see that 2 also divides 8. So this is the example for this statement, for this theorem. Now, how to prove whether root 2, root 5 or root 3, whatever given in the question, is irrational? First step is assume the opposite. In mathematics, whenever you are asked to prove or disprove a statement, start by already assuming something else, by assuming the opposite. In this case, assume that root 5 is rational. If root 5 is rational, according to our definition of a rational number, root 5 should be represented as p by q, can be written as p by q, where q not equal to 0, p comma q belongs to z plus whatever, z, yeah. Now, once we can write this as p by q, let's now square the terms, rearrange the terms and play around with it. So I cross multiply q and square on both sides. So 5q square is equal to p square. That's what I get. Now you can see again that in the table of 5 into something gives me p square, means the table of 5, multiplication table of 5, p will definitely come somewhere. So it means that 5 divides p square. By FTA, fundamental theorem of arithmetic, 5 also divides p, and p can be written as 5 times k. Something multiplied with 5 gives me p. Now I'll substitute this back here. 5q square is equal to 25k square. Q square is equal to 5k square. And again you can see that 5 divides q square, 5 divides q. So what we found, what the observation is that 5 divides both p and q, which means that both have a common factor 5. But our initial assumption was that p and q are co-primes, which means that they cannot have any other common factor than 1. But as we proved, p and q both have a common factor 5, which means our initial assumption was wrong. It means, therefore, root 5 is an irrational number. This is the proof. For example, if you are asked to prove root 2 is a rational or irrational number, it has the exact same procedure. Assume it to be rational, write in the form of a by b or p by q, cross multiply, square on both sides, show that there is a common factor other than 1, then it means our initial assumption was wrong and p and q are not co-primes, and therefore root 2, root 3, root 7, root 5 is an irrational number. So there are a couple more categories to this, types to this question. So here we are asked to prove 5 minus root 3 is an irrational number. So step 1, assume it is rational. Assume rational. And if it is rational, 5 minus root 3 is a by b or p by q, whatever, with the conditions, of course. And our target in these type of questions is to isolate the irrational number. So for the prerequisite to solving this question, is knowing that root 3 is irrational. What we are trying to do in this question is isolating the irrational and then grouping together rational terms and equating both and saying that one side there is rational, one side there is irrational. So both can't be true, our initial assumption is wrong. That's the approach that we are trying to use in this question. So I'm going to take the root 3 that side and bring a by b here. 5 minus a by b equal to root 3. Since a by b is literally written in the form of p by q, which means it's a rational number, and 5 is a rational number, so the difference will also be a rational number. And you can see, so LH is a rational number, and RHS is an irrational number. So our initial assumption is wrong. Therefore 5 minus root 3 is irrational. Okay, that's the proof, and you can try this, prove that 6 plus root 2 is irrational. Say assume as a by b, take root to some side and show that this is rational, this is irrational. Both can't be true, so our initial assumption is wrong. Good. Now to prove 3 root 2 is irrational, same, write this, assume 3 root 2 is rational, write 3 root 2 as p by q with the conditions, and cross multiply. 3 root 2 is p by 3q, and this is say a by b. Say this is on simplifying p by 3q, I get some a by b. Again, this is a rational number, this is an irrational number. LHS not equal to RHS. LHS is an irrational number, RHS is a rational number. Therefore our assumption is wrong, and 3 root 2 cannot be rational, therefore it's irrational number. The same can be done for this as well. 1 by root 2, assume p by q, isolate root 2, say that this q by p is a rational number, and but root 2 is an irrational number, therefore our assumption is wrong and it's an irrational number. So that's the general approach to solving these type of problems. Thank you.